Okay, hello everyone and welcome to today's session. This is session 2, the second of our two-part series, the importance of front-end planning, leveraging industry best practices to improve front-end planning. Throughout this presentation, we'd love to hear from you, so at the bottom of your window is a Q&A button. Please submit your questions there, and we will be holding all questions until the end of the presentation. Our presenters today will be Feroz Ashraf and Michael Dubreuil. As I mentioned, my name is Jeremy Rasmussen, and I'm the Chief Technology Officer at PTAG, and I'll be your moderator. Feroz?
Thank you, Jeremy. My name is Feroz Ashraf. Welcome all of you back to the seminars, and those of you who are new attendees in the second session. My name is Feroz Ashraf, Global Executive Advisor on Capital Projects at PTAG. I've had 33 plus years working for a major engineering construction firm as a process engineer, project manager, and project operations, as well as eventually the project responsible and executive for the global operation. Also had a chance to work with an operating company for several years as a chief project officer, chief operating officer, and a CEO. Bring in both the EPC side of the business, the construction side of it, as well as the owner side from the owner's perspective in investment. So I would be happy to do first part of the session today, and Mike will, second part, and Mike will do the first part. Mike, over to you.
Thanks, Feroz. Again, my name is Michael Dubreuil. I'm the Managing Director for PTAG. Like Feroz, I've been in the project world for over 35 years. And most recently, I've spent time at the Construction Industry Institute, working on improving industry best practices and looking at different contracting and delivery strategies. So with that, I'll move to the next slide. So just a bit of a recap from our presentation last week. In the agenda, we took you through the top reasons why projects go off track. One of the fundamental reasons was lack of planning, and hence these two seminars. That lack of planning causes us as an industry, industrial projects in particular, to be viewed as a failure by many. We have systemic cost, schedule, and performance issues. And so last week we talked to you about front-end planning and a phased approach to using CII's defined phases. There's lots of other ways to break your project up into phases. And then we looked at leveraging industry best practices to actually improve the front-end planning process. And we talked about why a disciplined stage gate process is critical to get the right sized for your projects based on complexity and priority. And Feroz, I'll let you talk to the last three.
Thank you, Michael. So in addition to the best practices, a disciplined stage gate process is critical, or I would say not only critical, but essential. So we talked about that, and then I moved down to after the disciplined stage gate process and you've identified the stage of deliverables, you need to set up your project properly and use the project management controls handbook or the integrated handbook. And we showed you our simplified version of the integrated handbook that provides a simple recipe to the project team at large to sort of follow the process. We also talked about project complexity model. Not all projects are the same. One size doesn't fit all. Many companies go with one standard recipe book, and we have found that you need to give a flexibility and adaptability to your project team. So we have developed a project complexity model, and depending on the project priority, we come up with a project delivery model. So if it's a simple process, we talked about a simple solution, simple execution plan. If it's a complex, high-risk project or high-impact project, you need to put in a lot more effort and rigor into it. And then last but not least, we said, defining the project management deliverable is important, but ensuring that appropriate project management elements are being used and on a prioritized basis, on a proper sequence basis to address all the complexity of the project is paramount. So today's session, we're going to be expanding a little bit more on that. We're going to be talking about, and over to you, Mike, for the start of the second session.
Sure. So as you can see from the agenda, it's a 6-part agenda. I'll take you through the first 3 elements: value engineering, project delivery and contracting strategy, as improvements to the front-end planning process. And then I'll walk you through what's known as an integrated project execution plan. That's based on the project delivery and contracting strategy example that I'm going to use today. And then Feroz will walk you through the last 4 elements here: rigorous project controls, risk analysis method, and more about an interactive project management and controls handbook. So with that, we'll just jump right into it. So the front-end planning process I selected to talk about today has been around for a while. Value engineering. It's a creative, structured method for driving value improvement in your project. The process includes reducing costs of developing your facility or your asset or your product without reducing its value. It's sometimes defined as a systematic application of recognized techniques that identify the elements of a facility or product, establishing the worth of these functions to meet the required performance of the facility at the lowest overall cost, something we call cost competitiveness. As an example, if you take a look at a pencil, there's various elements of the pencil: the eraser, the band, the barrel, the lead. And each of these elements has a function, and going through the functional analysis, maybe you can come up with a better eraser that removes marks better, or an eraser that has the same functionality but costs less to apply to your pencil. Same with the lead, the different types of lead. You may be able to reduce the cost of providing the lead, yet provide a superior way of marking your paper. Value is, so what you're looking to do is improve value, and value is a ratio of the element function to cost. Several different formulas for that, from function divided by cost. A little broader is the worth of that function divided by cost, and probably the broadest definition of value is satisfaction of your needs to the use of resources. Just think of the pencil. If you enjoy using the pencil and you take all of those elements, that's value. What value engineering is not a cost-cutting exercise. Simply by removing the eraser, we can reduce the cost of the pencil, but then you lose the function of being able to reduce the marks you make on paper when you do make a mistake. So value engineering has a history where it came out of World War II as a reaction to shortage of parts, labor, and raw materials. And then following the World War II, Lawrence Miles from GE formalized this process and really revamped how engineering is done. And as we're going to talk to it, value engineering is done through all phases of a project, but it has particular value during the front-end planning process. In particular, the driver coming out of World War II was the fact that the Allies lost access to all the rubber plantations in Southeast Asia. And it took the United States government, along with industry, to come up with synthetic rubber that we all benefit from today. And so why use value engineering? Original or conventional methods, designs, ideas are not always the most functional or the most cost effective. As an example, and so we look for alternatives to improve the value. One thing to think about is construction cost, design and construction cost of a facility is only a small fraction of the total life cycle of costs of that major facility, and can be as little as 10, 11%. And when you think about manufacturing, and the investment cost in your manufacturing facility, ongoing labor, maintenance, production rates, downtime account for much more than the cost of designing and building your manufacturing facility. Value engineering is a process. It's not a one and done. It's not a calculation. It starts with an information phase and works through to actually implementing the value improvement process. The chart on the right-hand side takes us through the various elements, from identifying the basic functions and elements of your asset as you came through the early phases of your project. And as you enter, once you understand those, you enter into a creative phase, brainstorming and identifying alternatives. At this stage, no alternative is crazy. Everything goes down or goes up on the wall. And we walk through an evaluation phase where we analyze the functions and the benefits of these alternatives, and we rank them against each other and against the original element that was in the original project. Then as we move from evaluation phase into the development phase, we're looking to select the most viable alternatives. And usually we're looking to provide more than one alternative, but the most viable alternatives, and do a comparative analysis of those to the original major elements. We present that back to the owner or to the project team, and they make some decisions, they choose, and then the selected alternative is then developed further, going into the detailed design phase of the project. So that's kind of the value engineering process in a nutshell. One of the best practices that you'll see out there in the literature is a recommendation to use a third-party facilitator and SMEs from multiple organizations to prevent groupthink. Just think, you got to your first set of elements and alternatives with the internal group, and if they had better ideas, they would have used them. So the idea is to bring some outside resources, other parts of the organization to the table as you go through your value engineering exercise. If you take a look at the different phases and the things that happen through a project, from concept to commissioning and turnover at the end, value engineering comes in a couple of places. One early, midway through concept, you're looking at simplification type value engineering. A little later, as you get down into detailed scope, you're now looking at specific elements and you're considering alternatives, different ways of achieving, maybe looking at alternative to pumps, alternative forms of generating electricity, alternative building structures, etc. Value engineering, while it's can be performed at all phases, it's better earlier in the project. The potential to improve value moves up as the project phases occur earlier and earlier. Another way to say that is value decreases with each progressive phase of the project. And so as we move on to contract delivery and contracting strategy, selecting a PDCS is a core deliverable of the front-end planning process. Ideally, it's done during the concept phase to allow for the early participation of key suppliers. Tools such as the Construction Industry Institute, they have a tool that's, funnily enough, called a PDCS, and it provides a list of contracting alternatives in a method, a controlled method for going through all the various elements of your project, the various aspects, your business goals, your supplier arrangements, your environmental requirements, etc. And it helps you select one of up to 12 different contracting strategies. It encourages the decision makers to identify and focus on the project objectives and other critical success factors early in the project planning phase. It enhances insight to the contracting strategy that you did select through, as I talked about, systematic consideration of all the decision variables. It provides a defensible rationale for why you picked the contracting strategy you did based on quantification of the various contracting and delivery strategy alternatives. And we believe that the PDCS as a tool should be used as a standard, as part of, or a best practice that's part of your front end process. And, you know, one of the criteria for determining what type of contracting strategy that you need to make may be, as in this example, is the level of engineering that you've achieved. And that can help you. So depending on when you need to make that decision, you know, you may be at very different levels of engineering. So as you've made a decision, in this case, for the example I've chosen today, you've made the decision that says we're going to select our contracting strategy based on early cost and schedule certainty as being paramount business objectives on a complex multi-supplier industrial project, what we call I2PD, or an industrial integrated project delivery. It's a collaborative and integrated approach to project contracting and delivering. And it's ideally suited for businesses that are looking for early cost and schedule certainty in their projects. I2PD increases speed, trust, and transparency as a contracting strategy, and it delivers project outcome certainty, delivers faster designs, and integrated and accelerated execution than as compared to more traditional delivery methods. And its key benefit is the improved and early cost certainty and schedule certainty. You know, if you look at traditional delivery methods, contracting strategies, design, bid, build, based on risk transfer, hierarchical decision making, and purpose, competitive approach, win-lose approach, and what's best for me, depending on what side of the coin I sit on, owner, engineer, contractor. We evolved over time into more comprehensive delivery methods, EPC, EPCM, construction management risk. And we included more elements such as earlier involvement of key players, co-location, front-end planning, and partnering sessions. And yet we still ended up with the challenges we face today with poor performance of major projects in the industrial sector. So industry continued to develop, and in the early 90s, alliancing coming out of Britain and moving over to Australia and New Zealand developed. In 2000, in North America, we developed integrated project delivery for commercial projects. And all of those brought together additional functions in the contracting and delivery methods, including relational contracting, multi-party agreements, shared risk reward, equitable decision-making, and a best for project culture versus a best for me culture. And all of that has led to the development of I2PD as a delivery method that brings the owner, the engineer, project managers, general contractors, others into the project. So as trust, collaboration, integration, and open communication increase, we find that under this delivery method, that improve safety, early cost and schedule certainty, and design are optimized. So what type of projects can I2PD deliver? I2PD was designed and came out of the Construction Industry Institute, and it was aimed at infrastructure projects, industrial projects, and all of the 5 sectors that we see here. I won't read through the various examples, but the researchers showed that if you're looking to fast track a project with certainty of outcome, I2PD is a good project delivery method to select in your project, and we think is an evolving best practice. And if you've gone down that collaborative approach to picking your contracting strategy, that lends you to having the opportunity to develop what we call here is an integrated project execution plan, using that's developed here in the front end phases. Traditionally, we recognize the project execution plan as the project baseline and governing document for the project. It establishes the terms, scopes, contractual requirements, schedule, construction methods, HSC, cost, schedule. It describes the project plan in both a strategic way and a tactical way. And typically the project execution plan is developed by internal participants led by the project manager and approved by company management prior to publishing and moving forward into planning and execution. It's a living document, and it's updated and evolved and grows into ever more detail as you move through the phases of your project. Where an IPEP involves all key internal and external participants, what we call the project team, and its development is led by the project manager of all the key project stakeholders, including the owners, engineers, major equipment suppliers, and constructors. In looking at an integrated project execution plan, table of contents, and then the table of contents of a project execution plan for a more traditional approach, what you'll see is that there's not a lot of difference in the table of contents. Where the difference occurs is inside each of the subject areas. And it has to do with the fact that you have a team of people who bring a broader range of experience, knowledge, risk, and capabilities to the formation of that execution plan. So things like integrated project administration, information management, where you have project communications that are now developed and improved across all of the key stakeholders. Take a look at item number 6, contract management. You have an integrated risk reward plan. Under construction, typically depending on your project, you may have several labor agreements. Here it's integrated, and you may have your labor provided, even though you have multiple constructors at the table, you may have your labor managed by a single party representing the whole project. Quality management is developed early on the project and has input from all participants. So the real difference between an integrated project execution plan and an ordinary project execution plan is the content of the plan based on the input of the parties and bringing the right people to the table to make the right decisions as you develop your plan. Typical benefits that come out of an IPEP are a thorough and consistent understanding of the scope. The scope is developed through a series of big room meetings and scope reviews so that everybody has the same understanding and they're not coming to the project with a different set of assumptions on what they believe the scope is. There's an alignment on project objectives. There's an understanding of risk that Feroz will talk about later in more detail, but it's now consistent. There's enhanced communications, as I talked about earlier. There's, through the use of an integrated project execution plan, change in claims are reduced. Which lead to lower project contingency and improved HSC outcomes. And with that, I am going to turn it over to Feroz.
Thank you, Mike, and thank you, Jeremy. I'm going to cover 3 topics today: project controls, risk analysis, and how we can integrate all of that in a simple handbook for the quick recipe for the project team. So what is project controls? In many 30 years of my life, I've asked that questions to my team members. I've asked it to the owners, engineers, and project controls managers and others. And, you know, project controls is such an important subject, and yet we don't get a consistent answer. I have a view on it, and the view is project controls and project management information system is the key element of a front-end planning process. Most of the time, many team members say we are so focused on doing our basic engineering, our feasibility study. We don't have a project controls manager on the job yet. We will hire the project controls manager in the execution phase of the project because we are not controlling much. The dollar value we're spending is few. And my answer is that's exactly the issue. In many instances, you need to plan your project controls philosophy and your system ahead, because it takes 3 months, 6 months, sometimes a year to layer it out properly and make sure that everybody is in the full sync. So if you look at the data collection mode, you need to decide what is the information you're going to collect at the ground level. You need to make sure that you have a methodology to measure the progress. And I find that a lot of companies use different methods, different templates to measure the progress, irrespective of it. As long as the measurement progress meets your requirement and it's based on your company's philosophy, stick to it. You don't need to change it unless there is a drastic problem in one of the areas. More importantly, you really must, the whole idea of a data collection and progress measurement is not to measure the progress. There is no need to find out, hey, I'm traveling at 90 kilometers an hour, 100 kilometers an hour. Question is, are you within the speed limit? 1, 2, and are you going to reach there on time? Yes or no? And of course, the most important is to really forecast and provide an insight to your management as to where the project is. That's the key function. If you set up the project, plan it, execute it, if you don't control it, you will not be able to monitor and steer the project in the right direction. Project controls is like a headlight for the project management team. Process is very simple. It's like somebody asked me, what are the 5 steps to do the project? Define the scope, put the best practices, put the good team, do the execution, stick to the mandate. Having said that, these are 5 simple steps. And yet we find that hundreds of projects go off track when they deviate from any one of these elements. And the answer is, if you deviate 5% from one element and 5% from the other, and 5% from the other, and what really happens at the end of the day, the construction, the cumulative effect is really 1.05 raised to the power of 5. That's how it magnifies. So anyways, make sure your project controls methodology is correct. It is all about interrelationship of data collection, progress management, and performance assessment. Is 10% of the project data, which gives 90% of the value, and yet people end up collecting hundreds and hundreds and percent of the data. I'm not suggesting you don't collect the data. I'm saying make sure your data is well established and screened. I asked a lot of people during the project interviews. In fact, we met with 2 or 3 different companies, and I asked them, I said, do you all know what your project management flow is, and can you draw it for me? And I asked the project controls manager, project manager, engineering managers of different companies to draw their own simple chart. And I said, you are allowed to make 10, 15 boxes, no more than that, or maybe 5, 6 boxes. And I was and you know that I wasn't surprised to see that I've got, if there were 15 people in the room, I got maybe 12 versions of the flow diagram. Why is that? It's because people know what the flow diagram is, but in reality, there is a workflow process. And I'm not saying this is the perfect vision of a flow process, but you need to define it. So it starts with the project coding structure. The blue boxes where you see in the fronts are really led initially by the project managers and project controls manager. You need to set up how you're going to do the estimate, how you're going to develop the estimate. I did talk about how you take the estimate and you convert into project controls budget through the work breakdown structure. And once you have done the project work breakdown structure, I also talked about in the last session how you can make it into a contract management CBH structure. But all that steps need to be identified. Second is you need to prepare the schedule, and I'm going to talk a little bit about schedule as well. And once you have the schedule, the cost, you are then set up to do what is called the trending. And from the trending, you can do the change management. Once you have the contract management and formation in space, you can do the change management and forecasting. You do the risk analysis. And then, of course, you identify critical issues, whether it be cost, schedule, or otherwise, and issue the report for corrective action. So look, different elements of it. Setup stage in the blue, contract management in pink or red. Green is really where the decision making and analysis come in. A lot of time. In fact, we interviewed a recent company, and we found from the team they were spending 25 days collecting and analyzing the data, calendar days, and they spent 2 days putting it together, and the last day just doing the analysis. The management really wanted the other way around. The management says, we want more analysis. We want more forecasting. Where is it going? And the team just wouldn't have time because they were too busy collecting too much. And the information flow, both from a system point of view and a workflow, was not aligned. So make sure that you align your workflow processes and your system accordingly. I talked about estimate development. So here we have developed an estimate development checklist. It's a 6-page, 7-page document. Some companies have a volumes on it. We've developed a simple check mark for you to know what the things look like. You just want to make sure the estimate development checklist is only to make sure that you haven't forgotten any item. This is not an estimate review process. It's an estimate making sure that you've gone through and added up all the items together. And then in our handbook, we have for different stages of the project, whether it be order of magnitude, pre-feasibility or feasibility stage, we have identified a number of steps here, from recommended methodology to what kind of a work breakdown structure and what kind of an accuracy range you're looking at, to the level of project contingency that you should expect, how you should develop a cost estimate plan, et cetera, including the basis of the estimate. Breaking down is and establishing a budget is the key. Planning is important, and I'm going to sort of like go through it fast because these are all, I would say, easy to understand concept. Start your project scope, engineering deliverables. We have talked about all of these elements. And then Mac talked about project execution plan and integrated project execution plan. You develop a contract strategy, do the key milestones, identify your constraints, and make sure you're meeting the stakeholder requirements. You just got to make sure that you are moving from level 1 to 2 and 3 in the planning stage, and then level 4 and 5 in your execution stage. Just doing the schedule and establishing the work is first step. But this is, like a 3 years, 4 years life cycle of the project. You need to make sure that you have identified the basis of your schedule. If you don't do it, the schedule is going to evolve. You really don't know what your initial assumption was as you moved along. Make sure that that remains like a guidepost for your project. Again, we have identified what kind of schedule requirements are for different order of magnitude. It gives a clear guideline and a recipe to doing. It's not a perfect one, but again, it provides a simple thing. In many of our cases and our clients, we used to find that they would spend hours and hours, days, in fact, sometimes weeks, sometimes 2 months, debating, arguing, discussing, strategizing what level and what they need to do. Now, we provided them with some recipes, and what they do is they do it in 2-3 days, and now they're spending more time in optimizing the requirement rather than debating what needs to be done. They are spending more time how to do it rather than what to do it. And important also is they keep on asking themselves another important question. Why are we doing this? How can we optimize it further? Risk analysis, I'm going to go quickly on that. Risk, opportunity, and threats, simple definitions in the industry. You've seen it. And you know that you identify the risk, you prioritize them, you go through the response, you put the mitigation measures, you do the monitoring, and you keep on doing it for ongoing basis on your project. Risk analysis also means identifying the opportunity and improving. Mike talked about value engineering, value improvement. That's part of the opportunity scenarios. We have an opportunity register, and where each of the risk owners identifies the work breakdown structure, what is the opportunity chance, what is the opportunity outcome, and what the savings plus and minuses are. You need to look at that, develop a simple methodology. If not, we can help you with that. Also a threat register, you need to do the same, just different one. One is the opportunity, one is the threat. Then you go through the impact statement. It gives you visual heat map on it. It's a standard one, you've seen it. Greens are low, unlikely event. Red are critical, and yellow are moderate to high. Make sure that you've identified in terms of heat map, so when you present it, you can see it in a clear way. Basically, risk evaluation in a simplistic term is, when we look at it, expected monetary value or minimization of risk, whatever you call it, is a mathematical things of each individual risk and the probability, and you sum it up and you say, what is my residual risk? What is my sum total of net risk? What was my original risk? How much did I mitigate? How much of my residual risk that I have to monitor and make sure that I bring it down to zero? You don't want the risk to expand. Keep in mind, risk and performance are two different things. If you have a project performance issue, and your cost is overrunning, that does not necessarily mean you have a risk of an overrun, but you do not have increasing risk on the project. Well, make sure that you identify each risk and element and do it accordingly. Or you can do simple Monte Carlo simulation and take it from there. Accuracy is improved as you improve your level of engineering. You can see small concept to spending a full engineering design. Once you do that, you also drive down, improve the accuracy from plus minus 30–40% range to plus minus 10, and with the result, you actually lower down your contingency and minimize your risk. I'm going to show you a couple of slides over here. This is just to make a quick illustration, but I want to answer the questions later on. You see, when you start the project, you're on the red curve. It's very wide, it's very flat. It can go left all the way, it can go all the way to the right. And the idea is that as you're defining the project, you're decreasing the area under the curve, you're going to the blue line and probably a green line. And the green line has got less of a variance, so it improves the thing. You also need to know, and most people ask, I said, what kind of a curve do you have? Do you have a risk profile? You have a higher chance of underrunning or higher chance of overrunning? And most people tell me, oh, of course we have to come under budget. We have to come under budget. We have a high chance of underrunning it. And I said, but show it to me on a proper risk profile curve. And they end up showing me a curve which sometimes looks like this. That means they have a high chance of overrunning. This is a normal distribution curve. This is a skew to the left, which is called either a very conservative estimate or a very low risk estimate. So make sure you understand where you think. I mean, do you have your curve is on the left or right? It's extremely important. I'm not trying to get into a mathematical concept here. I'm just trying to say you should know what is the probability of meeting your project looks like. I talk about some standard deviations. So even though you have a same standard deviation sometimes, the curve to the left does not necessarily mean the curve to the center and the curve to the thing. So analyze it, whether you have a skewness on your project at what level. As you move in, make sure the contingency, most people say, oh, contingency is, I can use it for scope change, I can use it for management reserve and all of the above and things like that. And my answer is contingency is not a slush fund for scope change, is not a slush fund for other factors outside. It is a known unknown for the given scope of the project. Therefore, project contingency is integral part of your base estimate. Management reserve is another thing. Yes, management reserve can be for the additional scope for uncertainty that is control outside the control of the project team. Yes, And then sometimes you have what is called the cost overrun areas. And some companies go with a 50-50 probability, and some companies go with 70-80% probability for the cost estimate. So they start off with 50-50. I have done a recent survey, and I found that 90% of the companies actually go and seek approval for a 50-50 cost estimate. In other words, $100 million plus minus 30%, 50-50 probability. In other words, you have 50% chance of not meeting your schedule. But people say, yeah, but there's a probability of going down. I said, yes, but there's a probability of going up. But you know what the cumulative probability of going down and up is? And that's when I tell them, this is your contingency. Your probability of coming down, the base estimate, is the area, the small triangle over here, which is 10% of the probability. The probability of you finishing the project somewhere here is 80% or 90% of the curve of the probability. So, hey, all things are not equal. Make sure that in this particular case, we did the analysis for one particular client, and they were surprised, a little surprised. And they went out and they had sought the approval for $19.5 million plus minus 10, 20%. And when I told them, I said, by the way, you have 80% probability that your project, all things being equal, it's going to come at 21.5. And they said, but we don't have 21.5. I said, but this is the high probability you will end up spending that amount of money. And they were in the early stage of the project. So they did discuss it. They did the value engineering, brought this cost down a little bit. And when they finished this project, they finished close to $20.8 million. In other words, don't have a myopic eyeglasses to say that you start with the 50-50 rules and then you will not. The idea of an estimate is not where you start from, where you're going to end up in the project cycle. So finally, I'm going to just talk about the handbook. In the last session one, I did tell you what are the 10 importance approach to planning a project. I'm not going to go into the detail from kickoff to prioritization and everything. We talked about that. Today, I talked a little bit more about project risks, site planning, look ahead plan. I talked about that. But the more important one is, even though you've planned the project, even though you've done everything, you've done all the best practices, if you don't have a simple guide and tool for your team to follow in a simple, logical way, and not just the top 10 people on the project, but all the 100 people or all the 10 people on the project, you will find that you don't have a alignment and strategy, which Mike had talked about. So our section one starts with project excellence and best practices. We talked about stage gate, then we talk about project setup. Then we go into cost management. We go into planning and scheduling in a systematic way. We talk about procurement and contract administration, 3 pages on that, 3 pages on progress and measurements, change management, quality management, because it's not about you met all the deliverables, but is it the right quality? Project risk management, how to do risk management on an ongoing basis, how you can analyze and report the project, and how you can hand over to construction in an effective way. So with that, I'm going to hand it over back, and this is all covered in a simple 60-page, 70-page book. It's like a simple GPS for your car. You can use tons and tons of papers. You can rely on your memory, or you can go and look at the GPS from time to time. This handbook is like an interactive live and agenda. So with that, Jeremy, I hand it over back to you for question and answers to you.
Awesome. Thank you, Feroz, and thank you, Michael. Again, you two jammed a lot of information into today's session. Thank you very much. Just before we get into the Q&A, we've got up there Feroz and Michael's contact information. Feel free to jot that down while we're doing the Q&A. And the QR codes there, you can use your smartphone to automatically add their contact information to your phone. Now with that, we've got our first question here from Cannon, and Michael, he asks, the PDCS is recommended to be done as an early concept stage. Can this decision be reviewed and changed at a later stage? And if so, what might be the potential impact in doing this?
Yeah, so absolutely, one of the things we all know about projects is you can make changes. The challenge is as you move through the various phases, the cost of those changes increase. You know, if you, for example, I'll use today's example. If you picked early in the stages in development, you picked a collaborative and integrated process for your project based on what the team at the time felt as they walked through the PDCS tool. But then time moved on and reality changes as it does. And the organization realized, you know, we have another fundamental driver that suggests that maybe we need to move from a collaborative approach to a EPC approach. Sure, absolutely. You know, we were on a project down and I think Kenan at dinner with you down in Houston. We were on a $15 billion refinery ethylene plant project that went from 3 major scopes in the end down to 1 scope where they took 2 of the big pieces out just because on financial considerations of the company and the opportunity to buy feedstock that they didn't need to refine. So absolutely, real life changes and contracting strategies have to change based on realities on a project.
Thanks. Just as a follow-on to that, how does early PDS decision align with value engineering done at different stages?
Well, actually, if just go through the example I used on value engineering, you know, best practice says use third parties, bring in subject matter experts from other organizations or other parts of your company. And so if those people are, as you pick your contracting strategy, you may have multiple parties already at the table. So it's much easier to bring in different views and elements as you go through the value engineering. So your contracting strategy can affect how many participants, how many external participants you bring to the table in the value engineering exercise. The idea is to bring different mindsets to the table from the group that actually came up with the list of alternatives at your concept phase. So yeah.
Great, thank you. Feroz, next one for you around risk analysis. Is there a shortcut to risk analysis?
There is no shortcut in life. Yeah, so what I presented was perhaps a simplistic version of the risk analysis. I've seen a volume of 200 pages of risk analysis, and in our handbook, we cover it in 3 pages. The 3 pages covers the basic elements of it, because in other words, what are the 2, 3, 4, 5, 10 major risks? And if you go through the risk analysis, and I've done through over 300 projects, I always find there are 4 or 5 elements in the project, and there are different elements for different projects that have 80% of the impact. In other words, 10% of the items have 90% of the impact. So focus on your big impact items. And if there is an item that sort of is going to skew your project by plus minus $100,000 and several $100 million worth of project, yeah, it's important. Every small element is important, but focus on the big. So I would say use a simple process, but don't take shortcut.
Yeah, I'm going to add to that. One of the things you talked about, Feroz, that I've found in my life is that people focus on the threats as they do the risk analysis, and they miss, especially on these big industrial projects, they miss millions and millions of dollars of real opportunity because they don't focus on the opportunity and they don't invest in the opportunity and develop them. And that can improve function, that can improve capacity, and that can reduce cost.
Yeah.
So, you know, and as you talked about, it can be part of your value engineering to identify other alternatives and opportunities.
Yeah.
But you need to carry them in your risk register.
Correct.
Michael, next one for you from Bob. How does interface management work differently in I2PD?
It works easier. In a simple answer, collaborative contracting, I2PD, commercial IPD, alliancing, interface management works better because you have a structured approach to bring the parties together and communicate, plan, and organize yourselves. Too often in the more traditional methods, and that's where interface management came about, is we recognized that we weren't managing the interfaces and the handoffs properly. So we developed this concept called interface management, and it had to be rigorous and controlled, but sometimes the contracting strategy that we selected was different with different parties. So the contracts themselves got in the way of managing interfaces effectively. So it's with the collaborative and integrated contracting strategies, it's a much simpler process because it's baked in to the project contract documents upfront.
And Jeremy, if I could just add to a point, in my former company, I did over 25 projects and analysis on we had a very integrated project management system. And so we did a very thorough analysis, and we found that each of the units were okay. It was at the interface point, the engineering and construction liaison and touch points, engineering and procurement touch points, engineering and contract touch points. Those interface points were the problem where items were missed out. So interface management is where everything happened. If you're not gonna do, I'm saying to you, if you can do one thing on a project, do interface management. Anyway, Jeremy, on.
Right. And just sticking with the theme of I2PD for a second, another question, Michael or Feroz, how does the reward sharing work on an I2PD setup? Is it based on assigned managed risk by each participant, or is it purely by dollar value?
So that depends on the parties and the project. And so the answer is yes, yes, and yes. It can be just based on the value of your contribution. It can be based on the strategic nature of your contribution. Maybe you got a smaller dollar scope, but a more critical scope. And ideally, it's designed to be multifaceted because you just don't want to drive dollar value or criticalness. Sometimes you want to drive behavior based on your risk-reward approach. And so what we found is having a tiered approach to how you win together or lose together matters. So it can be simple based on dollar value. It could be more complex based on behavior, based on the contribution of opportunities. Maybe the company that should get the biggest portion of the reward should be the one that delivered the most value through the delivery of new opportunities that lowered cost or increased functionality to the owner.
Thank you. Feroz, next one from you, asked by Robert, and he asks, projects in the same portfolio can greatly vary in terms of complexity from building a pencil to building a processing plant. Does the handbook address the different project controls templates for setting up a simple WBS versus a complex WBS as examples to monitor and analyze the project?
So I did show some examples in my orange table. If you saw that, that was orange table for one of the project delivery model but we have a project controls, scheduling, work breakdown templates for each of the 4 or 5 project delivery models that we have developed. PDM 1 to PDM 4 or 5, to a simple project, to a most complex project, yes, and it must be done. And if you don't do that, then basically, in fact, our project complexity model that I talked about in session 1 goes through project complexity, brings in the project priority, and then selects for you the project delivery model. That project delivery model, I said, simple project, simple process, simple plan, simple work breakdown. Complex projects can have as many as 3 levels or 4 levels of work breakdown. Simple projects can have a single level 1 project. Absolutely, you must do it. If you don't do it, you're not going to one size, in my opinion today, in my late career today, I'm realizing one size doesn't fit all. You need, there are so many other complexity in life on running a project. Don't make it extra complex when you don't need to do it. Make it simple.
Great, thank you. I've got, we're almost out of time. I've got, Michael, maybe a last question for you. If we can do a short answer, if not, we can follow up with the fellow afterwards. How to minimize clashes when managing interfaces in mega project? And is there any method to avoid it or transfer that risk contractually to a third party?
Yeah, wow. Short answer is yes, there's ways to do it. Longer answer is the ways to do it depends on the individual bilateral contracts that you have with the various parties where you're trying to do the interface management. If you look to the Construction Industry Institute, there's a research paper that talks about interface management and how to do interface management on large mega projects.
Great, thank you. And we do have a couple more questions, but we'll, for those who have answered them, we will follow up with you offline. Thank you, everybody, for attending today's session, the final part of our series on the importance of front-end planning. We wanted to bring to your attention that later on in the year, November, December, we are going to be having a force majeure webinar covering methods to manage risk and change resulting from COVID. And then as a continuation of this most recent webinar series, we're planning a follow-up focusing on leveraging best practices for the execution phase. And with that, have a great afternoon and thank you very much. And look for your inboxes for more information on this webinar and for our future ones. Take care.